Okay, so you've done TechInsights, a number of reports as to trends for 2026, and in this interview, we're talking about the Power Outlook report. You've identified a number of key trends for 2026, and the first is perhaps not too surprising. We've got this AI explosion, and as a result, data center power demand is skyrocketing, is sort of off the charts. So just tell us how big is this situation, if you like.
Yeah, that's a good question and really an exciting market to be in. What we observed is really the compute density is increasing a lot with the new IT racks that are emerging and going to the market. You had the Grace Blackwell from NVIDIA, which is one of the thing. Now you have the Vera Rubin from NVIDIA again. And next to this, you also have the hyperscalers racks that are customized, which also are growing in compute density. So the net result of that, what we do see is the installed capacity for data center compute was about 5 to 6 gigawatt per year in the past and not so far away. And now it's becoming more of a 10 to 20 gigawatt capacity addition per year that we are seeing really. We modeled that from the XPU demand that we have also modeled, and we measure that kind of level for capacity expansion. The result of that for the power semiconductor industry is really providing the power to this new demand that is really rising. And this is something that is challenging in the sense that multiple issues needs to be solved. First, the power density. You need to fit this amount of power that is obviously growing, but you don't have a large footprint to make it fit into the IT rack. So you need to increase the the power density, and therefore you need, the wide bandgap technologies to be employed much more than what it used to be in the past. So GaN and silicon carbide really are key technology to be into this market. Second thing, there are also pressure on efficiency because of the cost of this power. You need to have less losses than what used to be employed in the past. And again, wide bandgap material is doing a good job into this, and this is really a key technology for the power designer to employ. The next issue, I would say, is the power availability. And for that, it's really in the end of the hyperscaler, how they secure, the power generation to their data center to meet their needs and also keep the price stable where they are implanted. So the overall result of that, in the Outlook report, we expected the market to reach 4 billion, and we just released an update of that market, and we now estimate the market will reach 5 billion by 2026, end of this year, and it's gonna grow double digit, really impressive growth and opportunities for the entire industry.
And you mentioned the importance of the wide bandgap materials, and the second, I think, sort of finding was around silicon carbide, and you say it risks commoditization or consolidation. When you say risk, what does that mean? Does that just mean there's less value there for people, and therefore, as you say, consolidate, people will sort of step away? What do you see going on with silicon carbide?
Yep, that's also a good transition and good question. The silicon carbide industry has been really in a tough situation last year, as you know, and there are a number of companies that have, not stable market, not growing as it used to be in the past. What happened is there are an inventory being built. There has been a huge demand, especially for the EV market in the past 2 years. So 2023 was a great year for the automotive industry and silicon carbide in particular. And then what happened is the excess inventory that has been built has slowed down the market, and parallel to that, you also had some regulation that evolved that made the demand being weaker than anticipated. And both combined, the inventory that has been built before and the demand that has weakened, both have led to a market demand that has declined for this wide band gap material in 2025. So that's really what materialized in the last year. And in the meantime, since you had some extra capacity and inventory, people wanted to have, share of that market, and they made their selling price decline, especially on the material side, and coming from the Chinese player mainly. So they have taken some share. But the net result is the overall market for the substrate declined because of this selling price decline and because also of the over supply situation. So this is the meaning behind commoditization risk that we have pointed out, that in this situation, when you have extra capacity and price that are low, you have weaker players. They may be acquired by other bigger companies or simply go bankruptcy. And this is what we expect to happen in this year, to have the strongest player emerging from that situation. 2026, I think, will be a year where you see that materializing, and moving forward, 2027, you see the growth starting again from this material industry for the silicon carbide. And you have growing opportunities. We just discussed the data center market. The EV market will take over again because the EV adoption has not stopped, and it will restart since the inventory have been dragged down, and you need to replenish this inventory moving forward.
And I guess, and the next one, you say there'll be a new set of rules in the GaN business, and I guess GaN is potentially eating into silicon carbide market share in certain ways, and as well to add to silicon carbide sort of problems. But yeah, tell us, when you say new set of rules for GaN business, what are you meaning there?
Well, what we mean by that is this market was really dominated by the fabless foundry business model, sort of. You had some IDMs for sure, but in terms of volume, that what was being made, if you set apart the mobile fast charger that are built, by companies like InnoScience, which is an IDM, has its own capacity. Next to that, all of the other market opportunities were built from the fabless and foundry business model. And the fact that TSMC announced that it would exit the market from 2027 is really a key change in this industry. You have a number of companies that still are fabless. They need to produce their device, and they innovate to this market to seize the opportunity, and they need to requalify and to expand to new foundries. And this is, I think, what we meant in that key point, that the market will be transitioning. It's not an easy thing to transition this GaN process. It's really a complicated process that you need to master. And not every foundry is capable of doing that. So that will take some time to requalify. And you have a number of candidates that we have been identifying in the report. And next to this, you also have the IDMs that are the key strength. They have in-house process capabilities, and they can also measure their device, the key figure of merit, get the feedback from their customer. So they are really in the race also to take over this market and get more share from it. We see the market evolving from that standpoint, and we will be tracking it, since it's also a growing market opportunities with a lot of developments, higher voltage rating for this device, tackling opportunities in the high voltage applications, and also new technologies. We've seen, things like vertical GaN, being discussed in the industry for quite some time, and now it's materializing a bit more, getting closer to market reality.
Okay, and I guess continuing with the wide bandgap sort of focus, you say that China is heading towards, I don't know how close it is, but towards wide bandgap self-sufficiency. So, bearing in mind the size of their market, etc., that's going to have a big impact. So, where are we at the moment, if you like?
Yep. China, they have a huge capacity for legacy type power semiconductors. So they have everything which is MOSFET or even IGBT. They are strong in that domain. And in the last 2 years, I would say they have invested significantly in expanding to wide bandgap. They call that the third generation semiconductor. And silicon carbide and GaN have been part of this investment plan. Where we are now, I think they have installed capacity for material side and also for the device side. And we track that on a quarterly basis, the progress that they are making. Some companies, they are sampled device to OEMs already, and those are automotive grades device that they have sampled. Really the key, most difficult part, I would say, that you need to come up with and develop and have been qualified to your customer. They are solving, things like reliability issues to get the trust of their customer and really being part of the supply chain, which was not really the case in the last year and the year before. If you think about companies like CRRC or BYD Semiconductor, they have developed a product line for silicon carbide that they are incorporating into the EV supply chain. So now I think that second source, and it will become more and more competing approach from these players to tackle the market opportunity on the local ecosystem.
Okay, and then I think the final one of the key trends you highlight is an increasing focus on smart power management. I guess that's coming back slightly to what you said about data center. They making sure because there's such this high power demand, people need to use it in a smarter way, if you like, more efficient. But yeah, tell us what you think is going to be happening.
Yep. For the smart power management, what we meant is really the fact that you put more and more digital capacity into your power semiconductor circuit. The data center is a good example of that. You have all these voltage regulators that are around your GPU, and there needs to be digitally controlled. You have a huge number of phases that you need to master and accommodate around your GPU. Really need to turn on really fast. Your DI/DT is really, you have a huge requirement for that kind of parameter. And you also need to master the efficiency. So that means the control is shifting to more digital. And you need to make that fit into either the digital power controller, so the multi-phase digital controller that the industry has been developing. You can also think about putting some microcontroller, dealing with that charge. The other thing that we see is the progress in the BCD type process, and really the industry is scaling this BCD process to more advanced technology nodes that what used to be employed in the past. You've seen 65 nanometer for this type of process, and with that you can come up with more feature on your chip. So I've talked about the digital control. You can also embed more memory on chip to do more compute next to your power feature. So that's really what we are looking at. And we also expect things that happen in the packaging side of things. you know, incorporating the inductance directly next to your power stage is also another trend that we are observing that is driving a lot of development across the industry. And I think we will see also other things like digital telemetry or real-time optimization happening in that space.
Okay, and then if the data center market is the dominant one at the moment, you touched on the EV market. You say it's going to come back. So at the moment, it's quiet. And are there any other application areas where you see significant? So yeah, sort of what's happening with EVs and where else do you think is there potential growth?
Yep. Okay. We discussed about the data center and the auto. The other market we are tracking is, are the renewable energy market. That's also a big one that we must not forget because there are stakes around energy generation. The PV in particular, I think, is a strong one that is driving market opportunity for silicon carbide. And also a bit of a GaN for the low power part of the consumer grade type of PV. We are monitoring those. Another one that we are seeing is really in the industrial market field and things like robotics, digital automation. So industrial robotics is one. There are also a lot of talks around humanoid robots that are driving a lot of developments at this stage. So these robots, they are hitting the industrial market now, and the first deployment will happen, from this year and the next one. You have companies that have been developed that have developed their prototype and now hitting really the product. Last one we see is really the circuit protection and things like solid state circuit breaker. They now become more commonplace, eating into the data center market because you have really a security issue when you scale your IT rack into the much higher voltage that the people are trying to qualify. You need this kind of device, to really cut the power when you have an issue in your system much faster than what you can do with the electromechanical ones that used to be in the past. I would say those are the three main categories where we see growth happening next to the two other market we discussed.
Yeah. And then maybe just finally, geopolitics and semiconductors sort of seem to go hand in hand. We've talked a little bit about what China's doing to move towards wide bandgap self-sufficiency. Any other sort of trends? For example, I know Europe is particularly strong when it comes to power electronics. Do you see that continuing or expanding? Because I know I can't remember, is it they want to end up, I think, getting 20% of the global semiconductor market, and I think a lot of that's based on power electronics. But yeah, and any other sort of geopolitical trends that you've spotted?
There are some that we spotted. So you mentioned Europe, and I think that's a good example. So Europe has a huge ecosystem that it can leverage for power semiconductor. It also used to use the Chinese factory very much. And I think what you see now is they are really leveraging their ecosystem more in the sense that they are scaling their production capacity and optimizing the cost footprint of that. Example of this, the scaling toward larger diameter for the BCD type process is one example. So they are moving to 300 millimeter, really to have this much better power device performances. So they will improve on the key figure of merits and integrate more features on the die, as we discussed earlier. So that's one thing. And the second thing, they will improve on the cost competitiveness to kind of being able to better response to the competition coming from China. On silicon carbide is the same. They are all scaling to the 200 millimeter diameter and really scaling down the 150 millimeter production. And that's again to improve on the key figure of merits for the device that they are producing, and again improving on the cost of operation and competitiveness. North America, bit of the same. There is big trends for reshoring, the production capacity. That's being made through the IDM companies, and also you see a lot of the foundry business that are scaling their production to host more of the power electronic production capacity. And this is really what we are seeing. They are securing, the capacity for having more resiliency, and also the sovereignty topic is a big concern for both regions. And I think we'll see really strong spot for this region really populating.
Excellent. I mean, it's been great to chat, and thank you so much for sharing so many great insights into what's going on in a sort of fast-moving, exciting market. So, Cedric, really appreciate your time. Thank you.
You're welcome.